Okay, so that will be due next Monday. Sorry, Friday kayong klase. So next Friday. Okay, so I will be discussing the next topic. Okay, so seeds, we'll be talking about to establish the our definition of what is an acid or a base. That this is taught in high school. However, I'll include this in as part of your lab to explain what acids and bases are. Okay, so the simple definition or the first definition of an acid or a base is a substance that produces H3O plus ions in aqueous solution. So this is the Arrhenius definition of an acid. And if it is a base, then it is a substance that produces OH minus ions in aqueous solution. Okay, so in this definition of acids and bases, we need the water as the solvent because otherwise the definition won't work. Okay, so yung H plus, we sometimes use H plus to simplify chemical equations, but actually in solution, H plus doesn't exist on their own. It's attached to water. Sometimes we use H plus just to simplify equations. So that's why HCl is an acid because it gives H plus to the, it gives hydronium ions in solution. Okay, so Cl becomes an ion and H is attached to the water, so H3O plus. Okay. And the base is the same as the base. So for a base, you react with water to form OH minus in solution. So example is ammonia in plus water will give NH4 plus and OH minus. So that is the definition of an Arrhenius base. So may limitation tayo dyan because we're defining that we have to assume that we have a water solution since water is the solvent. Okay, so a strong base and a strong acid is one that completely dissociates. So a strong acid completely dissociates to form H3O plus ions. and a strong base completely dissociates to form OH minus concentration. So yung mga group 1 and group 2 hydroxides, these are sources of these are strong bases. So we have strong acids here that completely dissociates in water. 1:1 yan bali. So for every molecule or every mole of acid, you have 1 mole of H plus or H3O plus concentration in solution. Eh, sino tong iPhone? Di ko, if you want to join, no, ayusin niyo yung pangalan niyo. Hindi ko magpapapasok ng...
Sir, excuse me po, ako po yan. Papalit lang po ako ng device po. Kasi po, malulubat po. Sorry po, sir. Papalitan ko po yung name po.
Okay, so to make, so you have also weak acids and weak bases. That means in solution, they won't completely dissociate. Example of this is yung acetic acid sa vinegar. So out of 1,000 molecules, only 4 is converted to acetate ion. So apat lang sa 1,000 mag-create ng H3O+. So it's a weak acid. Same with a weak base. So hindi 1:1 yung dissociation niya. So out of thousands of molecules, only a few will react with water to form the hydroxide. So limited tayo sa definition ng Bronsted ng Arrhenius acid or bases. So to make it more general, with or without water, we use the concept of Bronsted-Lowry acids and bases. So an acid in the Bronsted-Lowry definition, the acid is a proton donor and the base is a proton acceptor. So an acid-base reaction is a proton transfer reaction. So laging may pair yan. So kung sa reactant ay acid siya, ang sa product niya magiging base yung yung acid. So example dito yung acetic acid mo magiging acetate ion. So this is the acid and the acetate ion is the conjugate base. So same thing with ammonia. So NH3 magiging NH4+. So this is the base reactant natin. So the conjugate acid will be NH4+. Okay, so yun, may transfer of electrons, may transfer of protons, and then you form these compounds. So take note, yung strength mo, so inversely proportional yung strength ng base, conjugate base mo. So kung gaano ka strong yung acid mo, ibig sabihin yung conjugate base mo mas magiging weak. So inverse yung relationship nila. Okay, so an acid can be positively charged, neutral, or negatively charged. So examples of each type are H3O+, H2CO3, and H2PO4. So a base can be negatively charged or neutral. So example are OH minus, Cl minus, or NH3. So the term monoprotic from the word itself, monoprotic, 1 H, diprotic, 2 H, triprotic, 3 Hs. So yeah, number of protons given up. So for monoprotic, you have HCl. For diprotic, you have H2CO3. For triprotic, you have H3PO4. So carbonic acid can give 1 proton to become the bicarbonate, and the bicarbonate ion can give up 1 proton to become the carbonate ion. So in the Bronsted-Lowry definition, we can define a amphiprotic substance. So it is a substance that can act as either an acid or base. So water is an important amphiprotic substance because it can accept a proton to become H3O plus or lose a proton to become OH minus. So it has to contain a hydrogen atom. That's important definition. But in organic chemistry, as we know that not all hydrogens in most compounds are given up. So in acetic acid, the only H that will be given up by the compound will be the one attached to the OH group attached to the carbonyl carbon. So yun sa carboxylic acid natin, matatanggal yung H. So hindi yan true for hydrocarbon chain. Okay, so not H's in your compound will dissociate. Okay, so there is an inverse relationship between the strength of acid and the strength of its base. So the stronger the acid, the weaker its conjugate base. So pinakita natin yan, no? So HCl is a strong acid. So yung conjugate base niya, Cl minus, will be a weak base. Okay, so pumapasok tayo sa concept ng acid-base equilibria. So sa solution, may mga molecules na magdi-dissociate, may mga molecules na hindi. So dyan pumapasok yung concept ng acid-base equilibria. So for example, HCl is a strong acid. It will completely dissociate into Cl minus and H3O plus. But if you have a weak acid, not every molecule will dissociate into H3O plus and the acetate ion. So if water is not present, so the same concept pa rin, no? May proton acceptor, proton donor. So the proton donor will be the acetic acid, the proton acceptor will be NH3. So the conjugate base of acetic acid will be acetate, and the conjugate acid of NH4 is NH3 is NH4 plus. Okay, so anyway, I'll skip some parts because this is not needed in biochemistry. Okay, so we enter the concept of an acid dissociation or acid ionization constant. So may ratio yan ng mga concentration that will give a value of Ka. So if you multiply the concentrations of the product divided by the concentrations of the reactants, ano ba sinabi ko? Yung products yung nasa numerator, yung reactants yung nasa denominator. So this will give you a value we call Ka, which is the acid ionization constant. Okay, so the Ka for acid, for example, is 1.8 times 10 to the negative 5. So maliit lang sa percentage nung acetic acid magdi-dissociate ng H+. Okay? So because if you use Ka, we have consistent na exponent na may negative number. So ang ginagamit na iba yung P value. Okay? So yung pKa will just be negative log of Ka. So kunin mo yung value, kunin mo yung log, tapos magiging negative value niya, yun yung pKa. So the value for acetic acid is 4.75. So if we study the values here, you will notice that there is an inverse reaction, inverse pattern. So for Ka, as it becomes smaller, As your Ka becomes smaller, then your pKa will become larger. So, inverse relationship nilang dalawa. So, anyway, I'll just skip this part, yung chemical reactions niya, which we do not need.